Have you ever watched a dragonfly? They are incredible. They can zip forward, backward, and even hover in one spot like a tiny helicopter. For hundreds of millions of years, these amazing insects have been the masters of the sky. Scientists and engineers, people like me, often look at nature to get cool ideas for new inventions. It's a field called biomimicry. Bio meaning life, and mimicry meaning to imitate. So we're imitating life. The way a dragonfly's wings work is a masterclass in aerodynamics, which is the science of how things move through the air. It's this natural genius that inspired a fantastic idea for a new kind of aircraft. Imagine if we could build something that flies with the same grace and skill as a dragonfly. What if we could build not just one, but a whole line of them, flying together like a train in the sky? This is the idea behind the Dragonfly train. It's a concept for a series of connected aircraft, each one designed to look and move like its insect namesake. This isn't just about looking cool, though it totally does. It's about using smart design, borrowed straight from nature, to solve tricky problems in aviation like how to fly efficiently and safely in a group. This futuristic vehicle could change how we think about travel. The core of this idea comes from the dragonfly's two pairs of wings, which are known as tandem wings. They can move independently, giving the dragonfly amazing control. Our dragonfly train takes this concept and applies it to a much larger scale. Each car of the train is its own aircraft, a dragonfly, with its own set of wings. By linking them together, we could transport more people or goods in a single coordinated flight. It's like a super efficient sky convoy, all thanks to the humble dragonfly that has been perfecting its flight for ages. It just goes to show you, some of the best ideas have been flying around for a very, very long time. So let's consider this. Science is all about observing the world around us and asking questions. When we see a dragonfly darting through the air, we can ask, how does it do that? And then, we can take it a step further and ask, how can we do that? That's the spark of innovation. By studying the dragonfly's body, its wings, and its movements, we can learn fundamental principles of flight. These principles can then be used to design incredible machines that were once just a dream. The dragonfly train is a perfect example of how observing a tiny insect can lead to big, world-changing ideas. Science. It's all around us. Now let's get into the nitty-gritty of the design. The wings on each dragonfly in the train are very special. They aren't like the wings on a regular airplane. Instead, they are what we call sharp triangular trapezoid tandem high wings. Wow, that's a mouthful. Let's break it down. Tandem means there are two sets of wings, one in front of the other, just like a real dragonfly. High wings means they are mounted on top of the fuselage, or the body of the aircraft. This placement gives the aircraft a lot of stability, making for a smoother ride. It's a key feature for keeping the train steady. The shape of these wings is the really clever part. A trapezoid is a four-sided shape with one pair of parallel sides, and in this case the wings are also triangular, coming to a sharp point. This sharp, angular design is incredibly important for how the Dragonfly train functions as a unit. When you have multiple aircraft flying this close together, you have to worry about their wings bumping into each other, especially during turns. The unique triangular trapezoid shape is engineered specifically to prevent that from happening. It's a geometric solution to a very real aerodynamic problem, ensuring the train can fly in tight formation. Think of it like this. If each aircraft had long, straight wings like a normal passenger jet, they would need a huge amount of space between them to turn safely. During a turn, the wingtip of the inner aircraft would move a shorter distance, while the wingtip of the outer aircraft would have to travel much further and faster, creating a risk of collision. But with the sharp triangular shape, the wings are more compact and swept back. This design minimizes the wings' outreach, allowing each dragonfly in the train to have its own space to maneuver without interfering with its neighbors. It's all about smart shapes for safe flying. Furthermore, the fuselage, the body of each dragonfly, is shaped like a boat's hull. This isn't just for looks. This design feature means that if the Dragonfly train ever needed to make an emergency landing on water, it could do so safely. The boat-like body would allow it to float, and it could even ski across the water's surface during landing, much like a seaplane. This dual-purpose design adds an extra layer of safety and versatility to the aircraft. It can handle the skies and the seas, making it a truly robust and well-thought-out machine, all inspired by nature's design. So, how does this amazing Dragonfly train make a sharp turn without causing a sky-high traffic jam? It all comes down to some very clever math and programming. When the lead dragonfly initiates a turn, let's say 20 degrees to the right, the other dragonflies in the train don't just copy the exact same move at the exact same time. If they did, their different positions in the line would cause their flight paths to cross and their wings to clash. That would be a catastrophe. Instead, the system uses a brilliant method to make sure every single aircraft turns safely and precisely, maintaining perfect formation throughout the maneuver. The secret is in adding what we call a bypass degree. For each Dragonfly car following the leader, a tiny extra angle is added to its turn. Let's imagine our 20-degree turn again. The second Dragonfly in the train might turn 20.5 degrees. The third one might turn 21 degrees, and so on down the line. This small, incremental increase in the turning angle for each subsequent craft ensures that their flight paths remain perfectly parallel, like lanes on a highway. It compensates for the fact that the aircraft on the outside of the turn have to travel a longer distance. This is an elegant solution to a complex problem. This calculated adjustment ensures that even in the sharpest of turns, a safe distance is always maintained between the wingtips of each Dragonfly. The onboard computers are constantly calculating these micro-adjustments in real time, responding instantly to the lead pilot's commands and to any atmospheric changes like wind. It's a beautiful dance of physics and computer science, happening hundreds of feet in the air. This level of precision is what allows the Dragonfly train to be so agile, mimicking the incredible maneuverability of its insect inspiration while carrying passengers or cargo safely inside. It's teamwork, automated and perfected. This system is what makes the Dragonfly train concept so revolutionary. It's not just a single aircraft, it's a coordinated, intelligent swarm. The ability to fly in such a tight, efficient formation saves a tremendous amount of energy. Each following Dragonfly can ride in the wake of the one in front of it, a phenomenon known as drafting, which reduces air resistance. This is similar to how geese fly in a V formation to conserve energy on long migrations. Once again, we see that nature had it figured out first. Our technology is just catching up, using math to replicate nature's genius. Now, let's compare our Dragonfly train to another popular futuristic aircraft idea, the saucer-shaped craft, sometimes called a saucer craft or part of a saucer train. These flying saucers are often imagined as sleek, circular vehicles that glide silently through the sky. While they look incredibly cool, their design comes with a completely different set of strengths and weaknesses compared to our Dragonfly. The biggest difference lies in their landing gear and their relationship with water. The circular shape of a saucer, while great for hovering, presents some unique challenges for taking off and landing safely. Because a saucer is perfectly round, it lacks the long, stable body of an airplane or our Dragonfly. To keep it from tipping over upon landing, a saucer craft needs very long landing gear, which we can call skid legs. These legs have to extend far out from the center of the craft to create a wide, stable base. Think of it like a tripod for a camera. You need the legs to be spread out to keep it from falling. These long skid legs are essential for stability on solid ground, but they also create a major limitation for the aircraft. They are not designed for every environment. Here's the problem. Those long, thin skid legs are terrible for water landings. Unlike the Dragonfly's boat-like fuselage, a saucer's body isn't shaped to float. If a saucer craft tried to land on water, its round body would likely dip and submerge. The long legs would just poke into the water, offering no support or buoyancy. It certainly couldn't ski across the surface like our Dragonfly can. This makes the saucer design much less versatile. It's built for solid ground and that's it. It's a specialist, whereas the Dragonfly is more of an all-rounder. So, when we invent and design new things, we have to think about what we want them to do. Do we need a vehicle that can hover perfectly and land in a specific, prepared spot? A saucer craft might be the answer. But if we want a flexible, safe, and efficient train that can travel long distances and handle different landing conditions, the Dragonfly design, inspired by nature, has some clear advantages. Seeing how different shapes lead to different abilities is a core part of engineering. From insects to flying saucers, the world of science is full of amazing ideas just waiting to be explored, so keep looking, keep asking questions, and keep inventing.